Good afternoon, ladies and gentlemen. Goeiemiddag, dames en here. Dumelang bome li bontate. So, we are back for our online engineering week session. Today, we are covering mechatronic engineering. Ek weet julle het lank gewag. Dit was vir die laaste paar oop dae, weet ek, was dit die groot vraag. Wanneer kry die NWU mechatroniese ingenieurswese? En vandag het ons baie goeie nuus. Mechatronies is nou deel van die boekei van rigtings wat aangebied word by die NWU. So while we are waiting, we will be just communicating the following things. Thank you for all you guys tuning in every day. Daar's van julle wat van die begin af elke middag 3 uur inskakel. Baie dankie vir julle. Dankie aan ons voornemende studente. Dankie aan jonger studente, ouers. Dankie vir die ouers. And you are more than welcome to ask questions. Whether you're a student, whether you're a prospective student, whether you're still a young learner at school, whether you're a parent, please don't hesitate to ask those questions. And right here at the top, you will see you have the chat function on YouTube. Please type those questions and we will be answering them live in the studio. Right. So to give us a bit of a background, we have in studio today Dr. Henry Maree, and he will be telling us more about mechatronic engineering, mechatroniese ingenieurswese. Goeiemiddag, Henry. Ek gaan sommer met die deur in die huis val. Eerstens vir jou sê baie welkom. En dan gee ons sommer die pad. Hoe het ons gekom by mechatroniese ingenieurswese and what does mechatronic engineering entail?
Right, well, good afternoon, everyone. I think I'll do it in English since it seems to be the most apt and some of the terms don't translate well. So mechatronic engineering initially was proposed in about 2011, sort of the same time when we initially started thinking about industrial engineering. And then it sort of went away, but became more important, and we had a lot of requests for do mechatronics. And after a lot of market studies and that sort of thing, we decided that it makes sense. And then the long road to getting it approved started. So what everybody perhaps does not know or not aware of is that there's several layers of approval. So you have to get the thing approved internally within our faculty. Then the university needs to decide if it makes financial sense. Then the Engineering Council of South Africa. Once they are all happy, there's about a year to year and a half review process from the Department of Higher Education and Training. And once they're happy, there's a few other documents and certificates that you need before you can present it. So all of this took about 5 years to get sorted. So eventually we're at the point where mechatronic engineering is officially launching next year. We'll be kicking off with the first 2 years. So first year for new enrollments. And guys that's already in our system, they can sort of land in the second year. Unfortunately, we can't progress third years at this point in time due to XI regulations. But there's some students that's indicated already that they would be willing to sort of hang around for a while to enter the mechatronics track. So in a nutshell, that's why it took so long. A lot of those processes are essentially out of our control. You can ask nicely, but that's about it in terms of getting a government department to hurry up. But either way, we're happy that we eventually managed to get it approved. I think what makes mechatronic engineering at the NWU unique is the way in which we've positioned it. So historically, if you consider mechatronic engineering, it is a specialist branch of engineering. So it's not a mixture of typically electronics and mechanical engineering. So that's a common misconception that it's a 50-50 mix, sort of a stew. But it is actually a speciality in its own right. And depending on the specific university that hosts it. So in South Africa, we've got mechatronics running at Stellenbosch University, at Nelson Mandela University in PE, and UCT in the Cape also runs mechatronic engineering, although they call it electromechanical engineering, which adds to the confusion. Since we have electromechanical Engineering, which UCT refers to as Mechatronic Engineering. So naming disaster. But either way, the mechatronics degree typically has a strong foundational leg in either the mechanical space or in the electronic space. So throughout the rest of the country, the typical base sits within the mechanical engineering sphere. So if you like percentages, it's about 80% mechanical engineering, some electronic stuff sprinkled in. But our perspective at Northwest was, given the whole drive towards the so-called Industry 4.0 and the whole Internet of Things thing, it becomes more apparent that the mechanical side of mechatronics is pretty much sorted out. So if you think about a self-driving car, the cars that we have today does not differ all that much from the thing old Ford came up with many moons ago. So, but what has changed is all of a sudden we've started sticking computers into everything. So you have a vehicle that's now all of a sudden trying to become a self-driving car, and that's much more programming centric than mechanical engineering per se. However, having said that, if you are intent on manipulating the physical world by means of computing technology, so you want to program a computer to move around a robotic arm or do that self-driving car thing, you pretty much should understand some mechanical stuff like momentum and mass and things moving against time, since unfortunately, sad as it may be, we're all still bound by physical laws. So you can't ignore gravity, and things have speed and mass and momentum which you need to take account of. So our offering then is very much strongly aligned to the existing computer electronic curriculum with regards to the programming side of things. And we flipped the ratio around. So in our case, it's 80% computer electronic engineering and about 20% coming from the mechanical side in terms of strength of materials, structures, dynamics of movement, that sort of thing. And that's sort of where we aim to position our branch of mechatronic engineering. So it's unique in terms of the country. It's the only mechatronics program presented in the northern part of South Africa. So all the other guys are down at the coast. And our sort of location relative to the agricultural sector and mining plays to our strength. So we intend to have a focus towards processing of agricultural crops, so beneficiation of agricultural yield. Some of the mining stuff, although mining is a bit of a weird one at this point in time, but there's a lot of drive towards automation of mining. And then a little bit of a lesser focus, but one that seems to be coming more into the fray, would be biomedical devices. So stuff like intelligent prosthetics and that sort of thing, which essentially boils down to a mechatronic system. So there's some mechanical thing, it's under computer control, and we want to position graduates in that space. So using computing technology to control the physical.
Baie dankie Henry, dis 'n mond vol, maar ek gaan 'n paar dinge net uitlig. Wat jy eerstens gesê het is, daar's goeie nuus vir leerders wat nog op skool is, wat mechatronies oorweeg, van volgende jaar af geen probleem, hulle sal kan inskakel, maar ek hoor ook daar's goeie nuus vir eerstejaars en tweedejaars veral, as jy hoër op is, reeds by die NWI en rekenaar elektroniese ingenieurswese swat, gaan jy dalk 'n rukkie net moet wag, 'n jaar of ekstra moet aanhang. So daai is positiewe nuus, ek hou baie van wat ek hoor. Dan wat ek ook hoor jy sê is, all mechatronic engineering degrees are equal, but some are more equal than others. Die punt van die saak is, die punt van die saak is, die woord elektromeganies en die woord mechatronies, daar is nie eers in Suid-Afrika noodwendig konsensus tussen die verskillende tersiêre instellings rakende wat dit presies behels nie. So, sal dit dus sin maak, hier is die vraag wat ek te sê, sal dit dus sin maak om eerstens te besef dat mechatronies in naam is nie oral dieselfde nie, as ek jou reg verstaan, en dit beteken 'n student wat belangstel in het sy mechatronies of elektromeganies moet baie seker maak wat is die inhoud van daardie kursus by die betrokke instelling, want verskillende instellings in Suid-Afrika, die naam is dalk dieselfde, maar dit gaan nie noodwendig dieselfde uitkomste hê nie en jy gaan nie noodwendig by dieselfde plekke kan werk nie. Verstaan ek jou reg wat dit betref?
100% korrek. Ja, dit hang af, soos jy sê, die mechatroniese kwalifikasies, gaan afhangend van waar jy dit doen, gaan jy verskillende ervarings kry. So as ter voorbeeld, die graad wat Nelson Mandela aanbied, is baie nou gekoppel met die voertuigvervaardigingsindustrie, gegee hulle omliggende industrie is hoofsaaklik voertuigvervaardiging. Die ouens by Stellenbosch, dis 'n baie meer meganiese agtergrond, en hulle teikenmark is effektiewelik die omliggende industrie, so wynprodusente en dies meer, dis die tipe van industrie wat hulle teiken. Maar die ouens daar het vir my gesê, weet jy wat, jy sou kon werk as 'n meganiese ingenieur as dit moes.
Right.
Waar ons is meer na die ander kant toe. So ons probeer om 'n benadering te volg waar ons sê, wel, die meganies goed is belangrik, maar weet, daar's meganiese ingenieurs wat dit vir ons kan uitsorteer om hierdie ding sterk genoeg te kry. Ons wil ouens oplei wat verstaan hoe kry ons hierdie ding slim dat hy vir ons kan werk doen in die sogenaamde industrie 4.0 wêreld.
Wonderful. Thank you, Henry. So the message to those listening, please do yourself a favor. If this is the field you want to pursue, make sure you understand how it is put together, because it's not, and I can say this, for instance, if you study chemical engineering at a university in South Africa, regardless of where you study, in principle, the curriculum is almost the same. So it's regulated, it's clear, but it's a bit different in these two fields of electromechanical and mechatronic. So please, it's a note. Please note, it's not necessarily the same. So you will have to do a bit more homework with the specific institution. And as you heard, Dr. Marais just said, in many instances, the way in which this degree is presented depends on the geographic location of the postgraduate or the university where it is situated. So Henry, I have another question before we move on to an alumnus and a student we have in studio today. My question would then be, how does the curriculum look? And you can go into a bit of detail, because the big question will be, how does this differ from electronic, computer electronic, and then the one we will be discussing tomorrow, electromechanical? How does it differ curriculum-wise?
All right. Somewhat of a loaded question with a very long answer, but I think let's do the sort of headline takeaway first. Primarily, if you consider electrical engineering versus the rest, the focus is solely on generation and distribution of electrical energy. So think sort of the ESCOM kind of world. Computer electronic engineering tries to do things with computing technology, and the central aspect is information. So moving information around from point A to point B. And we use radio networks, computer networks, all the stuff in between. Mechanical or mechatronic engineering aims to apply computing technology to the physical world. So we want to control the physical world with computing technology, and typically it's going to be things that moves a little bit faster, and the faster will become clear in a moment. Electromechanical is a blend of electrical engineering and mechanical engineering, but on the large heavy machinery side. So I think a train typically on the electromechanical side is a good example, and a thing that packs features into a box on the mechatronic side. So it's different scales and different foci depending on which sort of blend you get yourself into. If we dig a bit into the curriculum specifics, the first year of study for all of the programs within our school, so that would be electrical, electronic, computer electronic, mechatronic, and electromechanical. The first year is identical for all of those programs, for the simple reason that they use the same fundamental building blocks. So it makes sense to have some generic component. In the second year, so in the first year, you'll do some programming modules and a bit of math, most engineering stuff, bit of math, bit of physics, some computer programming. And that's sort of first semester, and you'll learn how to draw nice pictures on a computer in a CAD tool. Second semester, we sort of start playing with little computers called microcontrollers. So it's more programming, but it's not a desktop computer. It's something really small, like the thing that goes into your washing machine. And more math, more physics. That sort of rounds out your first year. So after your first year, you've probably had an overdose of math already. And in your second year, we'll continue with the dosing of math yet again. So second year sees more math, more physics. And we start adding in additional programming modules. So moving from that little computer we had in the second semester of the first year, now we start thinking about algorithms. So how do you sort things, or how do you find the shortest path or the fastest way to do things, which just keeps it interesting between all of the math and physics, since it could get a little bit tedious just doing math and physics, and you want to study engineering after all. So those 3 semesters are pretty much generic between the programs. From the second semester of the second year onwards, there's a divergence between the programs. So electronic engineering and electromechanical engineering, they take sort of one track, and mechatronics, they head off in a direction, and the computer guys head off in a different direction. So the mechatronic guys, since that's what we're talking about this afternoon, they will start encountering modules that speaks towards the mechanical side of things. So strength of materials, structures. So you get your first exposure into how strong is a specific structure. And depending if you make a bridge out of plastic or steel, you'll have different results. And we'll have a look at how do you quantify which is best, quote unquote. There's not really a best, there's a solution, but either way. And that trend continues. So throughout your second year, we round out your mechanical foundation a bit more. So we introduce additional CAD tools, and now you'll learn how to create a part in the digital space and to assemble it to make a little thing. So it's almost like playing Legos in the virtual world. And the Legos are accurate to the nanoscale if you want it or need it to be. So that rounds out your second year. In your second year, you still play with one of those little computers in the second semester. And the focus there is, well, all of the things that's around us have some intelligence, and some of them need bigger brains than others. Third year rolls around, and we introduce the modeling of dynamic systems. So if we use my peach packing machine example from earlier, you'll have a box that moves. There'll probably be some actuation or an arm that picks up the peach and has to put it in the box. And you'll need to describe mathematically how this whole thing works, so that you can design a system that moves fast enough, that grabs the peach hard enough to pick it up but does not squish it, that sort of thing. So we look at those aspects. Second semester of the third year, we progress towards a design module, which we refer to as third year design. And that starts to roll together all of the modules leading up to that point. So typically it takes place in groups, and you'll build a project that actually accomplishes something. And that project will differ from year to year. Usually we keep it a bit of a secret until the semester starts, so that there's no unfair advantages. And it will be things like robots that pack stuff into boxes, or that fold boxes or package things. But you could even consider a 3D printer mechatronic system if you take it to an extreme. So that sort of rounds out your third year. Fourth year, we have a look at industrial automation. So all of the ways in which things move in industry. You've got motors, electrical motors, there's various types, there's pneumatic stuff, hydraulic stuff, and sensing. All of those things start coming to the fore. And then in the final semester of your fourth year, there's a module called virtual commissioning. And that's pretty much unique in South Africa. And I could only find 2 other universities at this point in time that sort of attempts to do something in that fashion. And the idea is that we have computing technology that's very powerful, pretty much sitting on your desk. And modern engineering tries to leverage those tools to essentially build the entire thing, whatever the thing is, in a digital domain first. So you'll find out that things are too big or won't fit through the door before you actually build it and then try and fit it through the door. So we try and provide students with a skill set that is something that the industry is increasingly demanding. We want to make sure that if we're going to build this thing and it's going to cost $100 million to do it, we want to know our $100 million will actually be spent well, and it won't be a $100 million experiment. That's sort of a bit wasteful if you're not a place like CERN or so. And then, as with any engineering degree, your 4th year has an individual design project, which you will work on for the entire year within the mechatronics space. And it's typically open to a sort of a selection process, but it will vary depending on specific things. So I think in a nutshell, that's pretty much the curriculum. If there's specific questions, I can get into the details. But in a nutshell, that's how it pans out.
Good. Thank you very much, Henry. That's a mouthful. As daar van die individu daar buite is wat wil kyk na die curriculum, wel die mechatroniese curriculum gaan nog nie aanlyn beskikbaar wees nie, want dit sal eers van volgende jaar af verskyn in die jaarboek. Maar soos reeds gesê is, die eerste jaar rekenaar elektronies, elektries elektronies, mechatronies en elektromeganies is identies. So wat 'n mens kan doen is, soek letterlik in Google NWU jaarboek 2020. En dan gaan jy 'n dokument daar kan aflaai wat al die vakke baie mooi uiteensit. If you really want to see exactly which subjects you're going to take with an explanation of what each of these subjects entail, you're more than welcome. Just Google NWU Yearbook 2020 and you will see undergraduate, under engineering undergraduate, you will find that document. Of course, at this point in time, the mechatronic curriculum is not fully available online yet because it will be phased in from next year, but this year already you can have an idea of what's going on. Ek het daai vraag gesien, Zana, dis die eerste deel van jou vraag in elk geval, Zana Kotse, en ek het jou vraag ook gesien, Jacob van der Walt. I've seen your questions. I will get to those questions now. I first want to introduce our next speaker, and that is Sarel Jansen van Rensburg. So Sarel is one of our alumni. So Sarel, welcome. Please give us a short introduction of who you are.
Hi, everybody. Thank you for the time. So yeah, I'm Sarel Jansen van Rensburg. I finished at the NVE in 2016. So I studied electrical and electronical engineering. And I've been thrown into the automation world, industrial automation world. I've been working for a company for 3 years now called PCS Global. We're known as system integrators. So we don't necessarily engineer, create projects ourselves. We actually integrate multiple systems. And what I can do for you today is I can share my screen with you and actually take you to one of the plants that we're working on. It's a chrome recovery plant in Rustenburg. So if you would so kindly, can I share my screen with you? Is it okay?
Yes, you're more than welcome to share your screen with us.
So I like to show something practically, and then everyone can kind of get an idea of what they will be working on. Okay, let me just share my screen. Okay, can everyone see my screen?
Yeah.
Okay, so you can see this.
Yeah, yeah.
Okay, so currently we have a system of pumps here that's taking the tailings from the mine. So that is basically the discharge of the mine, and they're trying to extract additional chrome. So just to give you a short preview is that we've got a motor. Hello?
Just change your screen. You're on Discord now.
Sorry, seems like I've got a bit of a technical difficulty here. Yeah, I think we should skip that for now. We move along. Sorry. Hi, you hear me?
Yes, Sarah. Yes, you must just select which. So if you want to share your screen, you must just check that you share the right screen. Otherwise, you share the Discord screen and then everybody can see us. And then you can just select the right screen to share. See, are we ready?
Okay, can you see this now?
Great. Then we can continue.
All right, yeah, sorry for the
Yes.
technical delay. Yeah, so currently this is a chrome recovery plant running in Rustenburg, Sibanya. So they take the
Right, just having some technical difficulties, such is life in this current new normal we're having. So Sarah is just selecting the right screen to share. And once he's up and running, we can just move over and watch exactly what he's doing. Right, that seems to be fine. Am I right? Are we
Okay,
ready
yes, there we
to
go.
jump over?
Okay, back again. All right, yeah, so this is a chrome recovery plant. We have a section.
Spring oor.
Say again.
There you go, Sarah.
All right. Hello. Yes. So as you see on my screen here, this is a chrome recovery plant. We take the tailings from the mine and we then process it through and we feed so we have a SCADA system running here, which is controlled with programmable logic controllers. We've got a section of valves and pumps that we use to move the material from a set of tanks, and we process it through cyclones, open and close valves. We've got auto controllers. We push the material through equipment they call reflux classifiers, which the chemical engineers can give you more detail about. But then they extract the chrome, and finally we send the chrome through to the stacker. And we've got a lot of sensors connected on the system, such as flow meters, level transmitters, load cells, which we use for monitoring and controlling of this entire plant. So yes, if you'd like to go into this industry, this is definitely something I would suggest. And this is typically a practical example of something you would work on. If I could just give you this quick overview. So this is what it typically would look like. So currently I can't start any of the motors because the plant is in a shutdown and I don't want to interfere with the operations on site. But this is just to give you guys a brief overview of what we do.
Corneels het ons verlaat. Right, so
Right.
Corneels is back again.
Okay. So, am I back?
And gone again. All right. So also, you showed us a SCADA system of that chrome recovery plant.
Yes.
Can you elaborate on the sort of PLC technology that you use? So you mentioned that you use PLCs. For the people listening, that's essentially an industrial control computer. So we use those things in industry to execute computer code to do things. In Sarol's case, that's to sort of start motors and weigh things and read sensors and all those sort of things. So what brand do you favor in terms of PLCs?
Okay, yeah. So the industry favorite, I'd say, is definitely Siemens. So that's what we use out there. And if you guys can maybe give training on Siemens, I know that NVE, they had some Siemens in there that gave an introductory training to PLCs. That would actually be a nice thing to attend. And I know they provide courses like that. And
yeah, well, that's actually an interesting sort of leads to an interesting segue. In your years with us, we had the sort of Siemens training. That's now been expanded. So we've gone from 2 Siemens courses to 4. And we present those courses to prospective students at a almost free cost in terms of what the going rate is in industry. So if you're an enrolled student at NWU, you could practically get I think it's about 100,000 Rand worth of Siemens courses for just about 5,000 bucks of additional cost. And we provide you with the actual Siemens certificate. So it's not an NWU thing, it's a Siemens thing that's presented. In our labs, that's been equipped with Siemens technology. So our brand new lab is ready and waiting for its first time entrance. And we've just spent about 6 million Rand on building that lab with all the latest Siemens goodies that we could lay our hands on.
Right. Am I back?
You're back.
I hope I'm back. I'm back. That's such good news to be back. Thank you very much, Henry, for standing in for me when the signal leaves us. At least you don't leave us. So I have 2 questions that I have from the floor. One is from Jaco van der Walt. Henry, I'm not going to ask you because I've asked you this a previous occasion. The question
let's ask it again.
Now I'm going to ask it again, but I'm just going to... Okay, but let's ask it again because it's interesting. What programming languages will we use? Okay, that's different. Not what should they prepare for. What will they be using in their 4 years of studying mechatronic engineering? That's perhaps a different question.
Yeah, it is slightly different. While our focus is not on sort of teaching a specific language, so we tend to use what works. For those little small computers, the default language is pretty much C, and in later years, C++. There's also some Python in the data analytics modules. There's a scientific computing platform called MATLAB, which has its own sort of language. And that's pretty much the bulk of it. So I'd say C, C++, MATLAB, and Python is the ones that we use at this point in time. But it could change at moment's notice depending on what we use and what makes sense to use. And obviously all of those PLCs, Siemens has a tool to program them in, but so too does the other vendors. So we need to make sure that graduates are able to help themselves if they're presented with an unknown language. But what we use is C, C++, and Python at the moment.
Thank you very much. Sarah, just out of curiosity, with which languages do you have to do there in your work?
So PLC has got specific languages, PLC for specific. there's an industry norm that they use. So all the PLCs uses a type of language. It's either ladder logic or function block logic. So we use a combination of them, ladder logic and function block, and then you can even go into structured text. So that's the three main languages that are used out here.
Thank you very much, Sarel. Maar dit bring my terug by wat ons al vroeër vir mekaar gesê het. Daar's nie 'n manier dat jy universiteit sou kan gaan en al die tale wat daar op die mark is, almal uit jou kop uit kan leer en kan gebruik nie. Daar's te veel. So dit vat my terug, Henry, as ek jou reg kan onthou wat jy laasweek gesê het, Dinsdag, naamlik dat punt 1 gaan programmering oor 'n bepaalde manier van dink om 'n probleem te konseptualiseer en dan op te los. Die taal is sekondêr. Primêr moet jy eers die probleem kan oplos en dit wat jy dan leer by die universiteit, gaan jy gebruik of jy kom by 'n plek waar Sarel tans werk en dan gaan jy 'n ander taal byleer, maar jy die beginsels is reeds daar. Dit gaan dieselfde bly. Die taal gaan jy dan aanleer en dan gaan jy 'n spesialis word in 'n bepaalde taal na gelang van waar jy gaan wees. Henry, did I answer that? Is that comment, is that accurate?
Yeah, I think it's fair. It's a fair comment. So I think what's important is engineers or people who can think. And a programming language is a tool, just as a spanner is a tool for a mechanical engineer. And depending on the type and size of bolt, the spanner will differ. For things where we program stuff, the spanner is a computer language, but you still need to be able to think first, since computers can't think for themselves. So you do the thinking and you tell the PC what to do, or the PLC if it's an industrial controller, and you use a language that's sort of suited to the task.
Baie dankie, Henry. Sarel, coming back to you, just out of curiosity, you studied electronic engineering, but your work now is that more in the field of mechatronic engineering. I just want to check that.
Yes, basically in industrial automation, but we do work in several industries, in pharmaceutical industries. We're running projects in solar industries. So that is the great thing about engineering, is that you're always faced with challenges and you're not working in the same industry every day. So every day is a new challenge.
Thank you very much, Sarel. I also see a trend. Every day we've seen the last week and a half talking to alumni in the workplace, and many of them saying they studied engineering X and are actually applying their skills in engineering field Y. And to me, that's positive in the sense that no, it's not necessarily so that when you study a certain degree that you will work in that degree for the rest of your life. You might have to migrate. And the second thing is, it is possible to migrate. Dis moontlik om 'n bepaalde stel vaardighede te leer binne een ingenieursgraad en jouself te kan herposisioneer in 'n ander veld om redes sekere beginsels van probleemoplossing is reeds aangeleer. So
wat ek wil add by die NWE, hulle gee vir mense al die tools wat jy nodig het in jou toolbox om daar buite te gaan en te gaan leer wat nodig is en om gedoen te word wat gedoen moet word, wat die kliënte van mens verwag.
Baie dankie, Sarel. Ek gaan sommer die volgende vraag ook vir jou ingooi. WG van Stella, shout out vir Stella. Wat is die modules vir eerstejaars in mechatronies? Dit het ons redelik klaar deurgegaan. Henry het dit in detail bespreek. So rewind 'n bietjie en dan kan jy mooi luister en die jaarboeke is ook aanlyn beskikbaar. Maar WG, jy het 'n tweede vraag gevra en Sarel, ek gaan dit vir jou vra want jy's in die industrie. Hoekom sal ek eerder mechatronies studeer as meganies? Why would I rather study mechatronic than mechanical? Well, it's sort of already answered, but I still want you to comment on that.
Yeah, if you look in the field out there with the Industry 4.0 and everything that's moving to electronics with computers and electrical vehicles, and everything is moving in that direction. So you can't solely just rely on a mechanical aspect. It's like Henry said, it's a marriage between the two. So if you go out in the industry, it would be best to have knowledge on both of the facets, the mechanical and the electrical side. Because myself, I studied only electrical and electronical, and sometimes we're faced with mechanical challenges that I wished I studied mechanical engineering and had some of those modules available. That would have helped me to solve some of the problems. So I think this would be a great thing to have, a module to have, to actually give everyone knowledge on both sides of the equation.
Yes, I think you're highlighting one of those things. Uh, People have the expectation you study 4 years engineering, regardless of what engineering it is, and you walk out at the end of 4 years and you should be a master of everything. And that's just not possible. It's just not. And that's why we also find in the engineering world, you will not find just one engineer working in a specific industry. You will find various engineers, and each one of them will be a specialist in their field, but they will have to work together. Henry, I'm going to ask another question. Tapiwanashe Kudoma, afternoon. You've been a regular questioning person, and I like your questions. So the question is it possible to practice programming during my gap year? So I'm assuming that Tapiwanashe is either taking a gap year now or taking a gap year next year. I'm not sure. But is it possible to practice programming? And if so, which type of computer programming is good for engineering? So that is the classic question, but let's put it out there again to you, Henry.
All right, I'll hazard a guess. Just one note, I'd like to add something to Vieche's question about the mechanical engineering versus mechatronics after this one. But in terms of getting yourself versed in programming, my suggestion would be pick something that's easy to learn. So probably these days, I'd suggest Python. It's easy to learn. The barrier to entry is pretty low, and there's a lot of resources online. If you want to go the free route, the Python guys have got a nice tutorial that you can sort of work through. And there's also a bunch of structured stuff by guys like Udemy and so forth, where you can pay 100 or 200 bucks and you get 30 or 40 hours worth of training from some person who is usually somewhat of an expert. So it depends on what your level of practicing is. If you're starting from scratch and a complete novice, something like an online course would probably be a little bit easier to get the ball rolling. But if you're a self-starter, you can get really far with YouTube and other free resources. But I'd say go with Python. It's easy to learn. It's widely used. And even within the faculty, we use a Python tool that I developed to process student records. So it's a tool that's actually being used in more places than one would think.
Dankie, Henry. So just to summarize that, and that's a message because this question has been coming up about every single afternoon. Is it a good idea to take IT additional to the maths and the physical science? Yes, it is a good idea. We would say that. It's not going to hurt you to do IT, but it's not a prerequisite. That's the first thing. Second of all, many prospective students have asked, if I go into one language, what to do? And the consensus around the table has been, you can go the Python route, you can go the C++ route, and all those will have some sort of YouTube videos that you can watch. But again, you need not do that prior to coming to the university. It's I sense there are either a lot of eager people, and if you're eager, I'm not going to stop you, please go. But if you're doing this because you are stressing, no need to stress. There are many people who arrive at the university without taking an IT-related module or subject at school level, and they still manage to finish their degrees. Right, so just to put that one in bed, I think we've covered that about, it was with about every single day this question was asked. So I hope this closes that question. Then Jaco van der Walt. Jaco, dankie vir jou opvolgvraag. Hy wil weet of mechatronies baie is soos die bou en die ontwerp van robotte. So, Sarah, I'm going to ask you to answer that. Is mechatronics a lot like building and designing robots? And then I'll switch over to Henry. So the both of you can answer whatever you feel you want to say. Sarah, you are muted. You must just unmute yourself and talk to the nation.
My apologies. I've got experience in the industrial automation, and from practically what we're doing, we haven't developed robots, but from a mechatronics engineer, I think it depends on what you choose, you want to follow and pursue in your dreams. If you want to go and you want to build robots, you will find that mechatronics will be the means to the end. So yes, to answer that question, it would be, it can be used to develop robots. If you would, do you have anything to add, Henry?
Yeah, Cyril, I think your answer is a good one. A robot's an interesting thing since it depends on who you ask. A system that automatically recovers chrome and keep things in check, that could be an automated system. Most people, if you think about a robot, is either something like the open dog thing from Boston Dynamics or a robotic arm that welds cars together. So you'll certainly have the required skills to do that. But what's important to remember is that last year we took our third year group to the largest brewery in Africa, in Elroad. And the head of plant automation there said, well, actually there's one or two companies in the world that designs bottle filling machines, and they just sort of buy them and integrate them. So pretty much close to what Sorrel does. So if you want to do really low-level robotic design, my suggestion would be mechatronics would be a good start, but you'll most likely need some postgraduate stuff going into the details. And even then, you'll need to make a choice in terms of which subset. So a robotic arm is a mechanical thing, but there's also a lot of electricity and motors going into it, or hydraulics, and a lot of control. And to get all of that in one person simply is not going to happen. So you'll have a team working on it, and you'll have to decide in which facet of that team do you see yourself. So small scale, yes, you'll be able to build a robot. If your idea of a robot is something like a 3D printer, go for it. If it's larger things, you'll most likely end up in a team, and you'll need to make a decision as to which role in the team do you want to play.
Thank you very much, Sorrel and Henry. Well, before we continue, I have some questions also here to ask. I'm going to introduce our student for today, who is Gernu Visser. Welcome, Gernu. Tell us a bit about yourself. From where are you? And why did you decide to study engineering? And what is your dream? Where are you heading with your engineering degree?
Yes. Ek is Gernu Visser. Ek is 'n huidige tweedejaars student vir rekenaarelektronies. So nie mechatronies nie, maar as ek kon oorkies sou ek moontlik mechatronies kon kies. My familie kom meer uit 'n meganiese agtergrond, maar op skool het ek nou meer passie vir elektronika ontwikkel. So ek wil net die een weggooi nie. Ek wil graag of amper sê mengsel van een, maar my passie lê meer by elektronika. So ek het nou klomp klein projekkies op begin aanpak en so ek het nou vir my 'n drone begin bou wat ek self die flight controller gebou het en geprogrammeer het en so. Toe ek by universiteit kom, toe het ek vir Isak ontmoet wat nou besig is om my stream te manage. Hy het my eventually oortuig om 'n 3D printer te kry. En ek het baie vinnig agtergekom 'n 3D printer is eintlik meer van 'n mechatroniese stelsel as net meganies of net elektronies. So dit was hier lankie voordat ek Isak en een van die ander pelle ons eie printer begin bou het. Hy staan hier langs my op die oomblik, dit is moeilik om nou te wys. Dit was so, ons het so 'n paar maande gevat en ons scratch af gebou. Ons het begin by die meganiese stelsel en so stadig elektronika ingewerk en op die oomblik is dit aansienlik beter as enigeen wat ons op ons eie besit. Ek het nog nie gedink aan planne vir voorwaarts nie. Ja, ek het maar gehoop het sal kom nader in my finale jaar. My insig kry en waant ek sou wil gaan. Dankie.
Gernu, ek gaan vir jou 'n vraag vra. I'm going to ask you a question. Looking back, you're now approaching, you're in your second year, and so looking back, because many people watching today, they are on the brink of becoming students, what would you say is the most difficult subjects that you've had up to this point?
Okay. Die wiskunde is definitief moeilik, maar dit is daarom nog doenbaar. Ek het wel niks gehou van die fisika nie, ek het dit baie moeilik gevind. Maar die elektronika en die tegniese vakke was by ver my gunsteling.
Right, so there you have it, and that's something that you will hear many a student telling you. The mathematics can be very hard. So I'm putting it out there that nobody gets a fright when they get to university, and mathematics makes up a big portion of your subjects that you will have, and it's not necessarily that easy. But again, looking at the salaries of what engineers get, I think it's fair enough that you have to work hard in order to get that degree in the end. Right. Henry, I have a question that I want to ask you. And this is also a fundamental question. I know we will be talking about electromechanical engineering tomorrow, but because this is so delicate, the way in which it is combined, can you, and I know it's a loaded question again, but without going into too much detail, how do these two degrees differ, mechatronic and electromechanical? Can you perhaps just refer to application? Yes, that would be my question.
Yeah, I could hazard a guess. Let's put it that way. Fundamentally, there's a different philosophy of composition. So mechatronics is foundational in the sort of computer electronics sphere, and the intent is applying computing technology to control things. The electromechanical degree, juxtaposed to that is, I'd say, almost 50-50 between electrical engineering and mechanical engineering. But the price that you pay for that 50-50 is that you sort of end up sacrificing a lot of the details on the mechanical side and a lot of the details on the electrical side. So it seems to me at this point in time that the most of the electromechanical graduates, they end up in heavy industry as sort of the operations manager. So they are aware of the mechanical things and the electrical challenges, and there's some legislation things that also come into play. But it's typically a person that's trained for heavy industry. So that would be the electromechanical guy. The mechatronic guy is more of a process controls, automation, the behind the scenes sort of person. So in a nutshell, that I'd say that's the headline difference. But with any of these degrees, if you are sort of bouncing around between, should I do electromechanical, should I do mechatronic, maybe pure computer engineering is the best one. The moment that you decide that in any of those programs you would be sort of happy to a lesser degree or greater degree, does not really matter. That first 3 semesters is a time where you can experience the university and you'll make some friends and you'll see what senior students are doing. There's some industry tours. We try and get some experts to either organize some nice materials or take you somewhere. So it gives you a hands-on period to say, well, gee, I signed up for electromechanical engineering, but actually, you know what, mechatronics is sort of my thing. So, and then you can move and there's no impact. Or you think you like the mechatronic stuff, but you soon realize that the programming things are much more interesting and you're not really too keen on mechanical things. You'll rather build servers. And then you make the switch. So I think my number one suggestion would be, and that's typically what we tell students at the actual open day, which we don't have this year, is decide what you absolutely cannot tolerate or will not do for a job. So it might be that you find that chemicals are stinky, so you're not going to do chemical engineering at all. Never, ever, ever. And that at least eliminates something. And once you've done that, bite the bullet and stop. You can always move around a little bit, but if you've made a really wrong turn, it's becoming, well, it's not impossible, but it's expensive and tedious to turn around. So, but the difference between electromechanical and mechatronic is you'll find students like Harno and Isak and the rest that they play with things in their free time. So you'll be able to find an electromechanical guy that likes programming. It's not impossible, but from a curriculum perspective, the programming thing is not nearly as important in electromechanical. I think they've got 1 programming subject and 1 microcontroller module throughout the 4 years, as opposed to 8 or 9 modules for the mechatronic flavor. So I think there's a very big difference in terms of what the focus is.
Dankie Henry. Net om iets dan seker te maak. So elektronies, rekenaar elektronies, mechatronies en elektromeganies, daai 4 sy eerste jaar en 'n half is module gewys presies dieselfde. Ek wil net seker maak oor dit.
Yep.
Right. So the first year and a half of mechatronic, electromechanical, electronic, and computer electronic engineering, those 4 are exactly the same for the first year and a half. So if you know by heart, I want to do mechanical, nothing else, then you should go with mechanical. If you say, I'm a chemical engineer, I know it in my bones, then you should do chemical engineering. If you know you want to become an industrial engineer, you go for it. But if you are in this mix of the 4, where you say, I'm not really sure what I want to do. I don't know whether I want to do electronic, mechatronic, electromechanical, computer electronic. I don't know where I need to go. The good news is you basically have 18 months at university. You have that time to make an informed decision. That gives you another 18 months to get to know the faculty, to get to know the modules, to get to know in industry, where can I work with these degrees. So I think that takes a bit of the pressure it takes off. Dit vat 'n bietjie van die druk af wat daar rond mag wees. So met ander woorde, as jy in daai 4 rigtings belangstel, hoef jy nie nou al 'n besluit te maak. Jy kan enigiets van daai kies en jy sal 'n skuif kan maak binne die eerste 18 maande en jy sal geen agterstand hê en jy sal steeds in 4 jaar jou graad kan voltooi nie. So I think that's one of the advantages of these 4. And then we will talk tomorrow again about the differences. So just another question, and if you have questions, please type them right here. Right here, you can type those questions here because here we go. Zana Kotse, watter koshuis sal ek aanbeveel vir ingenieurstudente? Dis 'n interessante vraag. Ek wil gou net by wyse van hand opsteek, julle wat op die paneel is. Wie van julle was in koshuise op kampus gewees? Who of you were in residence? Sarel, nee. Isak, nee. Sarel, was jy in 'n koshuis gewees?
Ek was in 'n dorpskoshuis.
Okay, we're going to talk about that. I'll do that question. But let's quickly take that. Sarel, you were in what is called a what's it? Wat kom hulle in Engels? It's a dorpskoshuis. It's a off-campus residence. It's not a campus residence. Sarel, share your experience of that. Do you recommend going to a residence if you are an engineering student?
Certainly. I think you should go to any of the residences if you. Doesn't matter what you study. It actually helps you to meet people, and that's also another important facet of this whole engineering world. Is you work with people. Well, it depends on what area you work in, but there's always people that you work with. So you'll meet friends, and you'll work in conjunction to solve practicals that's laid out by your professors, and you'll have a nice job to finish all the practicals, and you'll build bonds. And I'm still in contact with friends that I had in university, and I'm sure we will be lifelong friends. And some of those friends I met in the hostels, so I would highly suggest it.
Zana, if I can just add to that, myself, way back when I was studying at the university, I was part of a campus residence, and my answer to this question, if people come to me and say, which residence and do you recommend it, yes or no, it depends. It depends on the personality of the specific student. Some students are ideal, they will love it. I studied my entire time at university. I was in a residence, I was actively involved in student life, and I finished my degree in 4 years. So that's always the big issue. Will I be able to go to a campus residence or a residence and be actively part in student life and still finish my degree? Yes, but it's a game of give and take. It's a whole question of priorities. You will need to work hard. Remember, engineering is not an easy degree. Jy gaan hard moet werk. En as mens dan in 'n koshuis is, jy steeds in staat om alles te kan doen wat moet gebeur, maar jy gaan moet kies. En soms gaan dit beteken jy gaan moet nee sê. Soms gaan jy moet nee sê vir die ekstra koffie 11:00 in die aand sodat jy by jou boeke kan uitkom. But saying that, the advantage of residence, and that's what I found, is you have buddies on your corridor, people studying with you. So if you are studying 12 o'clock at night, you can just walk over and ask somebody else, please assist. Again, that's also possible if you're not in a residence, but to answer your question, it can be any. Now we can go into detail which one of these residences. Some of them are closer, which means you will walk not that far. Some of them are further, but the long and the short is I will not venture into the field of saying this one versus that one. because I think that will just open up a can of worms and people will accuse me of being preferential. I say, if that's what you want to do, is dat wat jy wil doen, koshuis is op die eind van die dag wat jy daarvan maak. Dat kan ek ook in alle eerlikheid sê. Maar dit was 'n lekker tyd en ek dink almal wat in 'n kampus koshuis is, wat ingenieurswese sal swat sal vir jou sê dis baie lekker. Kyk gerus na laasweek Dinsdag. Nee, nie Dinsdag nie. Die studente lewe een. Dit was Dinsdag geweest. Ja, Dinsdag se video, dan praat ons lekker daaroor. Fantasties. As a concluding remark, Henry, I'm going to start with you and then Starla, I'll move to you. Just to give people out there an idea of which companies you can work for. So I assume you will be able to work for yourself. That's what we've gained from the last 2 weeks. You can work for yourself. But for which companies can you work with a mechatronic degree at the Northwest University? So you have to put that, remember again, all mechatronics are equal, but some are more equal than others. Specifically how this one was packed. Where will you be able to work?
Short answer, any place where they've got a plant or process under computer control would not be a problem at all. So that's the short answer.
Just for the sake of people not necessarily being able to think of examples, can you just name a couple of examples of companies that will fall into that category?
Well, I can give you a list of companies that's breaking down the door for students to employ. Unilever, Siemens, ABB, Anheuser-Busch InBev, the old SAB breweries. They are ABI, the guys who do bottling for Coca-Cola. All of those guys are in desperate need for people who can maintain their highly automated process plants. Since if the thing breaks down, the guy with the spanner is becoming increasingly less worth his weight in gold. Since if it's a computer program, a spanner won't fix it.
Thank you, Henry. Sarel, let's hear from your side.
So in industry, like I said, I work for a system integrator. So there's various system integrators out there. To name a couple, Afrelec, Systems Automation and Management, PCS Global that I work for, and the list goes on and on. But it's also a very specific field, and I've had a lot of recruiters contact even myself, and they're on the lookout for people. So there's definitely a need in the market for individuals with these type of skills, I would say. So the short answer is you won't struggle to find a job if you study engineering. There will always be something for you to do.
Baie dankie Sarel. Weer eens 'n baie positiewe boodskap vir mense wat kyk. 'n Ingenieursgraad is 'n goeie graad en as jy 'n goeie ingenieur is, sal daar altyd vir jou werk wees. Dit sê ek met alle eerlikheid. As jy in staat om hard te werk, jy kan 'n goeie ingenieur wees eendag, daar sal altyd werk wees. Because we are the people also creating work, and that's one thing we need to bear in mind. Right. I see no further questions, so we're going to do the classic go around final quotes. Gerno, ons gaan by jou begin. Jou boodskap aan die kykers daar buite. Hoekom sal jy sê moet hulle, ek weet jy's nou nie 'n mechatroniese ingenieur nie, want daar is nog nie op die NWU van hulle nie, dit is eers van volgende jaar af. But why would you tell somebody to study engineering, and then Henry specifically mechatronic, and then also Sarel specifically, why would you say somebody should study mechatronic engineering? Gerno, jy's eerste.
Dus ek sê ek het meer van 'n ek neig meer na die elektroniese kant toe, maar ek wil ook graag, ek stel ook belang in die meganiese aspek. Ek wil ook graag die meganiese aspek van leer, maar ek wil graag meer na die elektroniese kant lê as ek so kan stel. So ek sal sê iemand wat op die lyn is tussen elektronies en meganies, hulle is nie seker wat hulle vat nie, kan hulle met mechatronies begin en dan kan hulle van daar af aanbeweeg na of vir finaal besluit wat hulle nog graag wil doen.
Right. Henry?
Well, I study engineering. It's a way to future-proof your career. It's probably a good one. But if you like solving problems, study engineering. If you don't like solving problems and like routine, engineering is probably not for you. Why mechatronic engineering particularly? I think if you like the physical, or if you have a passion to control the physical world, so automated control, then mechatronic would probably be a good fit. So I'm hesitant to say one is better than the others, since it's a very personal thing. But if you see yourself in a world where there's always some physical thing around and you use a computer to control it, mechatronics is probably for you. And then one final remark, which ties into that hostile thing. Engineering is a team sport. So you better make some friends early on, since it's highly unlikely that you'll be able to get your head around all of the stuff on your own. So if you play the statistical game, a few friends helps a lot.
In Sarel.
Yes, so coming out of the industry, there's definitely a need for someone with electrical and mechanical background. You want to be kind of a jack of both of the trades and not a master, because that'll serve you better in the industry, from my experience. So yeah, that'll pave your way to a bright future.
Right. So I want to thank our panel this afternoon. Gerno Visser, baie dankie dat jy ingeskakel het. Dr. Henry Marie, baie dankie. En ook Sarel Jansen van Rensburg, thank you so much for tuning in. Also, so to our viewers, we've reached the end of this afternoon. So we have one session tomorrow on electromechanical. So if you understood mechatronic, now tomorrow we'll look at the other part, and that's electromechanical. Again, tomorrow at 3 o'clock, 3 uur môre middag, electromechanics, and then, very important, especially to the parents watching out there, if you are in grade 11 or grade 12, or you are a parent of a grade 11 and a grade 12, you should tune in Monday afternoon at 3 o'clock. We will have a team talking to us about an online tutoring program, which is specifically focusing on grade 11s and 12s, mathematics and physical science. Those two very important subjects. Dit sal daarso wees. En dan wat ek net ook wil vra, wat ek ook wil noem is, during the session, the executive dean, Professor Liesel van Dijk, she indicated she wants to be there for the finishing line. So if there are any general questions related to engineering, please tune in Monday. Our executive dean, Professor Liesel van Dijk, will be speaking to us. So asseblief, maandag as jy graad 11 of 12 is, daar's 'n tutorprogram wat beskikbaar is vir graad 11 en 12 wiskunde en fisiese wetenskap, meer as welkom om in te skakel. En dan ook ten slotte gaan ons uitvoerende dekaan Professor Liesel van Dijk beskikbaar wees vir enige vrae wat daar nog mag wees rakende ingenieurswese oor die algemeen. So with that, I wish you a wonderful evening. Mag dit goed gaan met julle almal. Salali gashle, usale sentle.